Hi everyone and welcome back. Today we're going to look at section 2.1, which is on derivatives and the rates of change. Hopefully you watched the intro video with Dr. Taylor and did those beginning video problems already. So today we're going to look at some more problems and make sure that you have everything filled out and are ready to move on to section 2.2 when all this is done. So one of the things I wanted to remind you about, and I know Dr. Taylor showed you this on the video, but please remember at the beginning of this section, we're looking at finding the slopes of a secant function, okay? And to do a secant, you still need 2 points. So I know that he explained that to you, but if you're looking at a graph, okay, a function that has a curve to it, and we ask you to find the slope between 2 points on that curve. Okay. The only way we know how to find the slope is to find the slope of a line. Okay. The slope formula that we know is 2 points on a line. So what we're doing in this section is we are creating a secant line, okay, which is a straight line that connects any 2 points on a curved graph, and we're going to find the slope of that line. So that is called a secant line, the line that connects 2 points of a curve, okay? And the whole idea of this section is that the closer we can get the 2 points on the curve to be, the closer we can actually find the slope of a tangent line, which would be just a line that goes through 1 point, okay? Because right now in algebra and all the classes you've had, we don't have a way to find the slope at 1 point. So that's what today's lesson is about. But we're going to start with 2 points as usual, okay? So I know that Dr. Taylor went over the formulas with you for slope. I hope all of you remember, it's rise over run. M is the letter for slope. Change in y over the change in x. This is the calculus way of talking about slope because change in y is just the difference of two y values. Change at x is the difference of the two x values. So that's still the slope formula, okay? And then down here, just to remind you, f of x and f of x2 and f of x1 is just another way to write y, right? That is the y value. So up here, if that's point x1, then up here would be the point f of x1. That's the y value. And the same thing over here. This would be the point x2. And its y value would be f of x2. Just another way to say y. So that's just function notation, okay? All right, so I'm going to jump down to number 2. That's the problem that we're going to do in class together. He did number 1 with you. So number 2 says, find the slope of the secant line to the function f of x equals the square root of x between x equals 1 and x equals 9. All right, so let's kind of just remember the square root function. Kind of looks like that shape, right? There's the square root function. And so here's the point 1. So if I put 1 in here, square root of 1 is 1. So there's an ordered pair. And over here at 9, our other x value, if I take the square root of 9, I get 3. So 9, 3 is my other point on the graph. So here's 1. And there's 3, okay? All right, so I have my ordered pairs, so I can find the slope of this secant line, which again would be the line, straight line that goes through both of those points, right? Straight line that goes through there. That's what the secant line is. All right, so I have my ordered pairs, 1, 1, and 3, 9. No, 1, 1, and 9, 3. Sorry about that. Okay, so there are my ordered pairs, so I can find the slope of the secant line, which would be y2 minus y1, so 3 minus 1 over x2 minus x1. So I end up with 2 over 8, which is 1/4. So that is the slope of the secant line, okay? Now, on the next page, which I wish part B was on this page with this problem, but we have a part B to this. I'm going to try to leave that up there. Okay, so part B says find the equation of the secant line to the same function. All right, well, remember, to start off with, to write the equation of a line, we need to have a point and we need to have the slope, right? So we have both of those from part A. You can use either point you want. I'm just going to use the 0.11, okay? Or I'll put here, you could use 9.3, but I'm going to use 1.1. And then the slope we just found to be 1/4. So once you have a point and a slope, you can write the equation of your line. I usually use the point slope formula. That's the easiest to start with, since we have a point and a slope. So there's your point slope formula that you need to know. You can also do this by starting with y equals mx plus b. If you do that, then you just have to solve for b, right? So I think this is a little bit quicker, a little bit easier. So we're going to do y minus y1, which is 1, and then equals 1/4 times, and then x minus x1, which is also 1. Okay, and then we'll just solve that for y. So y minus 1 equals 1/4 x minus 1/4. And then we're just going to add 1 to both sides. You can use your calculator for that, but if you add 1, that's 4/4, right? So 4/4 minus 1/4 should give you 3/4. So there is your equation of the secant line. Okay, so that's this line right here, the straight line that goes through those points. Okay, all right. Now, number 3 says to estimate the slope of the tangent line to the function y equals x squared at the point 1, 1. And then it says do that by calculating the slope of a secant line between x equals 1 and x equals 1.1. And then we're going to do it again between x equals 1 and 1.01. And then a third time x equals 1 to x equals 0.001. Okay, so let's kind of make sure you understand the difference in this question. This is asking us to find the slope of a tangent line. Okay, so remember what I told you. Tangent line, so here's the function x squared. I'm going to make it extra big so I can kind of show you. So here's x squared. Okay. All right, and if I go to the point 1, 1, right? 1 squared is 1. The tangent line is the line, straight line, that goes through that point and touches the curve. And draw that as close as I can. So a tangent line is the line that touches the curve at that point. Okay, so there, that line touches the curve right there. That's the tangent line, and that's what I'm trying to find the slope of. But think about it. The only way I know to have slope is I got to have 2 points so I can do the rise over the run, right? I got to have 2 points to connect to. So what we're getting ready to do is we're going to take this point, 1, 1, and then we're going to get closer and closer to it. So I'm going to spread this out just so that you can kind of understand. But let's say 1.1. So here's 1. Let's say 1.1 is way over here. So what I am going to do is find the slope of this line right here. Okay? And then I'm going to take 1.01, which might be here. And then that point would be, take that back. That's not there. 1.1 on the curve. So somewhere on the curve, I'm going to have another tangent line, another secant line. Sorry about that. Okay, so I'm going to find the slope of this line. Then I'm going to look at where is the point 1.01 on the curve, which maybe is here. And then I'm going to find the slope of that secant line. And then I'm going to do 1.001, which maybe is here. And I'm going to find the slope of that secant line. As I get closer and closer to 1, that secant line is going to start pretty much falling on the tangent line. And what is that we are doing? When we get closer and closer, we are finding the limit, okay? So that's what this is asking you to do. Let's find these slopes as we get closer and closer to 1. The distance between our 2 points is getting closer and closer. That's going to give us the limit. and that would be the actual value of the slope at that point right there. Okay, so I know I didn't kind of draw that well. We'll look again at another problem, but that's what we're getting ready to do. So I need to know all of the values for these points. Okay, so first thing I want to do is just find the function values. So I want to find f of 1, f of 1.1. I'm just going to do that now just to get it out of the way. So I need my x and my y values. We got to go to 1.01. Okay, so I'm just going to plug this into my calculator and find it using the table. Okay, so if you haven't done that yet, I'm going to go to y equals and plug in x squared. Okay, and then I'm going to go to the table, and remember I put my table, go to second window. If you didn't do that, put your independent variable on ask. Okay, so make sure that's on ask. Okay. And then go to your table, and you should have a blank table. If you have numbers here, just hit delete, hit your delete key, and those will go away. All right, and I'm just going to put in these numbers: 1, 1.1, 1.01, 1.001. That's just the quickest way to find those values. Okay, so there's my ordered pairs. Okay. Now, these are rounded off. I'm using more of the whole numbers here so that I can actually kind of see what I'm going towards. So you calculate a rounded here. If we put these in the home screen, so if I did 1.001 and actually squared it here, that's where I'm getting those numbers from. Okay, so I want that to confuse you why I didn't write those down. Remember, WebWorks does not like you to round. Okay, you'll find that out if you round too much. It's going to tell you you have the wrong answer. So I'm using the whole values just so that when you guys do your problem, if you have one like this, you will do the same. All right, so remember, these are the ordered pairs. So first one I'm going to do is right here. Find the secant, the slope of the secant line between this. So these are not hard problems. We're just doing the slope formula. Okay, so I need these two values. So this part first. So we're going to look at the points 1, 1 and the point 1.1, 1.21. So there's my x1, y1, x2, y2. So I'm going to find the slope of that. So I'm going to do 1.21 minus 1 over 1.1 minus 1. Okay, so I'm just doing my slope formulas. So that's going to give me 0.21 over 0.1, and that gives me 2.1. Okay, so there's the slope of that first secant line. So that was the slope of the points farthest apart. That's the steepest slope right there. All right, now we're going to find the slope of the next group, these two. So now we're going to use the points 1, 1, and then the point that goes with 1.01. So this one. So we're going to use that as x1, y1. And we're going to use 1.01, 1.0201. Okay. So we're going to find the slope of that. That's your x2, y2. All right, so 1.0201 minus 1 over 1.01 minus 1. So we're just going to do the slope for that. That gives us 0.0201 over 0.01. And that gives us 2.01. Okay? All right, we're going to do this a third time. I'm having a little trouble thinking today, I think. Okay, so now we're going to do the third one between x equals 1 and x equals 0.1001, which is the closest set of points. All right, so I'm going to write those ordered pairs down. Okay, so there's those set of points. And again, x1, y1, x2, y2. Find the slope of that. So this is just doing your slope formula 3 times, but we need to find the limit. So that is what we're doing. Okay, so we work that out. We get 0.002001 divided by 0.001, and that's going to give you 2.001. Okay, so again, think about what we're doing. We're finding slopes of the secant line as the secant lines get closer and closer to the second point being right on top of this point. And as we do that, the secant line is going to get closer and closer to looking like the tangent line. Okay, so that is a limit problem. So I don't really have the algebra to write, but I will say, so what we're doing, we're trying to find the slope of the tangent line, okay, at x equals 1. Okay, so we're trying to find the slope of the tangent line at x equals 1. And now we're doing that by finding these secant values of lines that are getting closer and closer to that. Okay, so that is the limit as x approaches 1, and I'm going to, again, just writing this out. The slope of the secant lines as the change in y and the change in x get closer or approach 0. Right? So the distance between them was getting closer and closer. So if you look at that, 2.1, 2.01, 2.001, so those values are approaching the number 2. So there is the slope of the tangent line. The slope of that line right there is 2, and I found it by using those other coordinate order pairs that are close to it. Okay, limit problem. Okay. All right. Okay, so you can pause it if you are still writing that down. All right, so now we're going to do this generalization here. And I know Dr. Taylor went through this with you, so let's just look at it real quick. So a generalization of the previous example gives us this definition that the slope is the limit as x approaches a, and then again, this is just the slope formula. F of x, that would be your y2, minus f of a, that's your y1, and then this is x2 minus xa. Okay, and we do that by defining the distance between x and a as the letter h. Okay, so again, what we're trying to do is get the x minus a part as close to 0 as we can. We want the distance between the 2 points we're finding to be really close together. Okay, so again, if I'm looking for the tangent line right here, the closer I can get to this point, if I'm right up against it, then the secant line is going to pretty much be the same line, so we can find that slope. All right, so if we look at this, and this is kind of important, and I'm going to write this out on the next few pages as well. I think this will help you out. So we have on this side, finding the slope of a tangent line at a specific point, okay? At some specific, they're going to give you, x equals 1 or 2 or whatever. This is going to be, this side, finding the slope of the tangent line at a general point, okay, that point that we don't know. So what I'm going to tell you here, not so much that it's a point you don't know, but this is going to be basically finding the derivative or finding the slope. And I'm going to just write of a function, okay? So you'll see that coming up on the next few pages. So this is at a specific point. This is when we want to just find the slope of a function anywhere, okay? No specific point at all. All right, so if you'll notice, we start off pretty much the same way with the slope formula, the change in y over the change in x, y2 minus y1 over x2 minus x1, okay? In this case, x1 is just the point A, okay? So we'd have to find the value of y, right? Just like we did earlier. We plugged them into the function and we got the y values, okay? So that's what that is. Now, on this side, okay, we're not going to give you a specific point. So we're just picking some point, some second point that's h units away from x. So we call the second point x plus h. We don't know how far away it is. You know, over here it was 1.01, 1.01. Here we're not going to tell you. So you're just going to use the notation x plus h, okay? Some small distance away. All right, so if this is x, then this is f of x. And if this is x plus h, remember the x coordinate, then the y coordinate would be f of x plus h. That's just the way you write the y coordinate. So again, this is y2 minus y1 over x2 minus x1. Okay, same thing, we're just, again, looks weird. And I know for some of you that is confusing, but they're all the same. It's just how you write x and y. Now this should look very familiar to all of you because in algebra, you learn the difference quotient. And this is the difference quotient. And the whole reason why you learn that in either pre-calculus or algebra is because now we're going to be using it all the time, which is how to find the slope at a point, okay? We're going to put the limit as h approaches 0 in here, and that difference quotient now actually becomes a definition of derivative, which we're getting ready to do. So this is why you did it, and this is why we keep kind of pounding that into you. Same reason we keep pounding on how to write the equation of a line, because you've seen already, we've done it how many times. All right, on this side, we're just going to keep it this way. And so instead of doing the limit as h approaches 0, we're going to go ahead and do the limit as x approaches that specific point. Remember, this is for a specific point, okay? All right. So down at the bottom, you have the definition of derivative. And I'm going to actually put a third thing on here, and we're going to write them on the next page. So right here, this f prime of x, that is the notation, one kind of notation. Isaac Newton, this is the Newtonian notation for derivative. There are others that we'll see in a little bit. Okay, so this is just one way to see that this is asking you to find the derivative. So f prime of x, that's how we say that, f prime of x, that is the derivative. And to find the derivative, you're going to do the limit as h approaches 0 of f of x plus h minus f of x over h, okay? That is how you find the slope of a tangent line of a function, okay? And I did mention up here, so I will say, how did that h happen down here? Remember, you have a positive x minus x, so those canceled out. So that's how I went from this denominator to just h. The x's canceled out there, right? So I forgot to mention that as we went through. Okay, so keep in mind that this piece right here, this one, okay, this is the definition of a derivative function, okay? This is when you're asked to find the derivative of a function. You're not going to be given a point. No point is given. This is important that you remember the difference. This is the derivative, okay, to find the derivative of a function at a point A. So this is definition of derivative. At a specific point, right? All right, so that's hugely different on when you're going to use these, okay? Okay, so keep that in mind. All right, now, some of you have learned we can change this a little bit and make it useful for the definition of a derivative at a specific point. So I'm going to put an arrow here, and I'm also going to write a new formula down here, because some of you know this. So we can also look at f prime of x, okay, as the limit as h goes to 0. And then we're just going to substitute in the point A here. So if I do get a point, I could do f of a plus h minus f of a over h. Now I can use this formula and I can find the derivative at a specific point. So you have two choices when you're asked to find the derivative of a function at a specific point. You can only use this function if you're finding the definition of a derivative of the function. Now, big asterisk down here, especially for those of you who took calculus before. In this section and in section 2.2, we will be using the definition of derivative to calculate all derivatives. So remember, you have to turn in your work to me. I must see the steps to finding this derivative by using this definition. Some of you know shortcuts. We'll start the shortcuts in section 2.3. But for this test and for these two sections, you must use the definitions. Okay, so you're going to use this one to find the derivative of a function. You can use either one of these to find the derivative at a specific point. And let's go back to the whole thing. What the heck is a derivative? The derivative is the slope of a function at a specific point. Okay, that's what we've been working on, finding the slope. So that is all that this means. Okay, so when you're doing the derivative at a specific point, remember that there's lots of things for slope. That's the average rate of change, right? We also learned that it's the average velocity, right? So we know that when we have 2 points, okay, when we're given any 2 points, we can find the slope, which is the average rate of change. We can use those 2 points to find the average velocity. But when we only have 1 point, then that's going to be instantaneous. That's going to be the instantaneous, if I can write and talk. Okay, it's instantaneous rate of change. And also the instantaneous velocity. So in physics, as you guys are learning this stuff, 2 points is always an average. We're just finding an average. So depending on the 2 points, those numbers will change. But once we do the derivative and we're doing 1 point, now we're looking at what we call instantaneous rates. Okay, so that's why the derivative is so important, because in the past, you didn't have that option. We only could do average. Now we'll be able to do the instantaneous, okay? Instantaneous, which is important for a lot of physics problems, and in other applications you'll see where that comes into play. Okay, so I spend a lot of time on this, but I want you to just see the difference. So, have these 3 formulas ready, because this one, again, you don't really have a choice, but these 2 you will. And I'm going to do some problems coming up where you'll see me using them both ways, so you'll know, okay? All right. So I'm going to do one more problem with you, and then I'll probably stop and do a part 2 video just again to try not to keep them more than 30 minutes, so we'll see how that goes. All right, so Dr. Taylor did number 4 with you, so I'm going to do number 5 with you. Now, we're going to do this both ways, because this says, find the derivative of the function f of x equals x squared plus 3x plus 10 using the difference quotient and the definition of derivative. Okay? All right, so I take that back. This is finding the derivative of a function. So we only have one way, okay? Only one way. So we're going to use the limit as h goes to 0, right? And then we're going to do f of x plus h minus f of x over h. Okay, so this is the derivative, f prime of x. So that's what we're getting ready to do. Find the derivative of this function. Notice there are no points. It doesn't say at x equals 1, at x equals 2, or whatever. Just find the definition, find the derivative using the definition of derivative of a function. Okay? All right, so let's remember the difference quotient and how that works. So we're going to do the limit as h goes to 0. Now, what does this mean? This means take your function and everywhere there's an x, you're going to replace it with x plus h. So we're going to write x plus h squared plus 3 times x plus h plus 10. That's what comes first. Okay, so we're going to do x plus h squared plus 3x plus h plus 10. And I'm going to put that in brackets just so that you can see it. That is just this piece right here. Okay? That's that piece. That's all of that. So all that means is take whatever function you're given and replace the x's with x plus h. So it's not hard. That's what you're doing. Then it says minus f of x. Well, what is f of x? F of x is the function you started with. Right? There is f of x. So you're going to minus this function, but be very careful. When you subtract the function, you need to put it in parentheses because you got to change those signs, right? You're subtracting every term, so that means all of those signs are going to change. And then this whole thing is over h. So if you can get it set up, that's the first big step. And then the second big step is that you can solve this without making careless algebra mistakes. Okay, so let's see. So now we're just going to work this out. So we're going to square x plus h. Okay, that's a FOIL problem. X plus h times x plus h. Right? That's what we're doing. That's outer, first, outer, inner, last, right? You don't just do x squared and h squared. Hopefully by now you know that is not how you solve that. So we're going to FOIL it. So x times x is x squared, outer is xh, and inner is xh. So that's 2xh, and then last is h squared. So when we square this, we get x squared plus 2xh plus h squared. Okay? We're going to distribute the 3 through. So plus 3x plus 3h. And we have the plus 10. Now we have to subtract the function. So each of those signs are going to change. Remember, this is like having a negative 1 out there, so we're multiplying every term by negative 1. So that's negative x squared minus 3x minus 10. All of that is over h. And remember, this is what you have to show me on your first test and on quizzes that have this information. If it says use the definition of derivative, this is what I expect to see. No shortcuts, okay? It's almost better if you don't know the shortcuts because then you can't do the shortcuts. All right, so let's see what I've got. X squared, and I have a minus x squared, so they're going to go out. I have a 2xh, and no other term that says xh, so I'll stick that there. I have h squared. Don't have another h squared to add to it. I have a positive 3x and a negative 3x, so those are going to cancel. 3h, I don't have any other h, so 3h. And then plus 10 minus 10, gone. All right, so now be very careful. When you divide by h, you have to divide each term by h. So you're going to take an h out of each of these, right? You can't just cancel that h. That is not how you divide. This is 2xh divided by h squared is divided by h, 3h is divided by h. So you must take one h out of each of those terms. Okay? So that's the limit as h goes to 0 of 2x plus h plus 3. Okay, so look at that. So I took the h out of here, that left me 2x. I took one of these h's out, so that left me h. And then I canceled that h with that h, so that left me 3. All right, so now I'm going to do my direct substitution and plug 0 in for h. So now I don't need the limit anymore. I'm going to do 2x plus 0 plus 3, and that gives me 2x plus 3. So there is the derivative function, okay? So f prime of x equals 2x plus 3. That is what we just found. That is the derivative of this function. So the function was x squared plus 3x plus 10, and there is its derivative. Okay. All right. So I'm going to stop here and pick up on part 2. So either continue or you can go back, look through the notes, start your homework. But there is another part to finish the rest of these notes. So I'll see you back here in a few minutes.